Good morning, everybody, and welcome to another installment of remote learning. Today, we are continuing our work with the properties of exponents. Just before we jump into the new one of the new ones we're going to encounter today, just want to remind us that when we raise a power to another power, we're able to multiply those two exponents together, keeping the base the same. This is called a power of a power property. And the other property that we encountered prior to vacation was called a product of powers. That's when you multiply powers that have a common base. You're able to add the exponents. So just wanted to remind us about those two properties that we've already encountered. So today we're going to be talking about a power of a quotient. And essentially what that says is that if you have a quotient or a fraction that's raised to a power, the exponentiation or the exponent will distribute over this division, meaning you're going to apply the power to each base in the numerator and the denominator. So for example, if we had x to the 7th over y, and that entire quotient or fraction being raised to the third power, we're going to apply this exponent or power of 3 to both the numerator and the denominator. And what we'll get is that we have this power of a power. So we're going to multiply these exponents together, and we'll finish with x to the power of 21 over y to the third power. And once again, we were just applying this exponent on the outside of the parentheses to each base in the numerator and the denominator. The next property that we're going to encounter is called quotient of powers, meaning we're dividing these powers. And just like this property here, the product of powers, where we needed to have the same base, that holds true here. So for the quotient of powers, we need to make sure that we're dealing with powers that have the same base. So if you divide powers with the same base, you may subtract the exponents and keep the base the same. The base is not going to change. What will change is the exponent. So if we were to have x to the power of 8 over x to the power of 2, we have the same base. We're able to subtract the exponents and land on x to the power of 6. And that's it. Nothing else to do there. And another quick example. The purpose of this problem is to re-emphasize the fact that we're dealing with fractions. And so the new piece of information is how we handle the w to the 7th over w to the 3rd. They have a common base. We're dividing these things, and so we're able to subtract the exponents, and that's why we get this w to the 4th here. But I just want to remind you folks that we're simplifying a fraction here. So these coefficients of 12 and 18, we're going to handle those as we've always handled fractions, dividing out common factors, which in this case, 12 and 16 share a greatest common factor of 6. And so we'll divide out those 6's. And the fraction 12/18 simplifies to 2/3. I'm just going to do two more examples on these two pieces. So as you can see here, we have two quotients or two fractions. One of them, the fraction in its entirety is being raised to the power of 2. So that's where we're going to put our energy initially. So we're applying this exponent of 2 to y squared and to x to the 4th. After multiplying the exponents together, we'll get y to the 4th over x to the 8th. Notice nothing happened over here on the left. What we're then going to do is we're going to rearrange this product. We're going to rearrange these two fractions so that we vertically align common bases. So we now have x to the 9th over x to the 8th, y to the 4th over y to the 3rd, and those bases are vertically aligned. We're dividing these, and when you divide powers with a common base, you may subtract the exponents. And so that's exactly what we're going to do. 9 minus 8, 4 minus 3. And of course, we know that that equals 1. And typically, we don't write the exponents when they are 1. However, you certainly can. And so either of these answers, would be acceptable. And then here, for our last example, we have x to the 7th over y to the 3rd. And we're being asked to simplify. And the response to this particular question is that we can't simplify it because the bases are not the same, which makes it so that we can't apply that property, the quotient of powers, which is predicated on the fact that you're dealing with powers that have a common base. So that's something we can't simplify, and we would leave the answer as such, stating that we can't simplify. Thanks everybody for watching. I hope you and your families are doing well, and I hope to see you soon. Thanks. Bye.